Welcome back, students. Let us do motion in a straight line. It is your chapter 2 of NCERT book. And even before we start, let us know some of the important terms and some of the definitions that we will be using quite often throughout the course. So we need to touch upon terms like mechanics, kinematics, dynamics, and then point object, the word motion, rest, and reference frame. Okay, so let us start with the mechanics. In physics, we study about the motion of the object. So when we study motion of the object, we study how to describe the motion. Okay, then we study what are the causes of the motion, in which force is there. We study about energy and terms like momentum. So everything related to motion of an object comes under the branch of physics, which is called mechanics. Mechanics is further divided into two parts. The first part is called kinematics, and the second part is dynamics. Kinematics is all about description of motion. So how to describe that the motion has happened. And dynamics is the study of the causes of motion. So we try to find out why the motion happened. So in dynamics, we study the cause of motion, and in kinematics, we study how to describe the motion. What is really interesting here is to know that what we are studying here in the coming 6 chapters is all about motion of things which are bigger in size. So we call it the macroscopic level. Okay, and in this we call this kind of a study as classical mechanics. Okay, then there is a new field of study which is called the quantum mechanics, that we will touch upon in class 12th. Is quite a revolutionary step in the study of physics. Quantum mechanics is the study of motion as well, but here the object is very small in size. So in quantum mechanics, we study the motion of microscopic objects, okay, such as atoms or electrons. So we call it subatomic particles. So if we study the motion of very small particles, it comes under the branch that is called quantum mechanics. And if the size of the object is big, observable, what you can see from your naked eyes, then we call it classical mechanics. We study the motion of the object. All right. So if the size of the object is too small compared to the distance it travels, then such objects can be considered as the point, okay, or the point object. For example, if we are going from suppose Mumbai to Goa, and we are using a car, so because the distance between Mumbai and Goa is quite big, so comparing that, in that respect, the size of the car is too small, okay, so we consider the whole car as the point object, just a point. Let me give you a very fancy definition of point object. I like it very much. So the definition is, ignore the dimensions, we call it a point object. That's it. So ignore the dimensions means ignore length, breadth, height, then whatever is there, that is just a point. So then we call that object a point object. And as you will study, you will come to know when we are doing graphs in physics, what do we do? Actually, there will be graphs. So it will be something like this. And every time you will see there will be 2 points in that graph, or maybe more than 2 points, and then the motion happens. So what happens? Motion happens by the point, this point. Okay, the point moves on the plane or in the space, and that's why we have this name called point object. In physics, it is very important to know about frames and reference points. So reference is one important word in physics. Suppose motion happens. A point object or an object moves from position A to different position B. It is almost impossible to know about the motion if there is no initial point or a reference point. For example, if a ship is sailing in the sea, what happens there? In the sea, in the middle of the sea, there is no land. You cannot see land. So it is really tough to, see that in which direction the motion is happening, without technology or without the compass that the sailors use, it is almost impossible to say in which direction the ship is moving, right? And also, trust me, if the speed of the ship is very slow and you are just looking up in the sky, then it is impossible even to say that the motion is happening or not. Okay, that's why there is a point very important to know about, is called the reference point. A point from which we can measure the position or locations. So the positions or locations. That point is called the reference point. Okay. To understand it better, for example, there is a tree. So let's make a tree. Now there is one cow. So let's make one cow, a four-footed animal. Now this cow is grazing. Okay. And you can say that after some time, the cow moves from point this to some different point. Okay. Now let's move this cow from here to different point. Okay. So how can we say the motion happened? Because if we compare the distance of the cow from the tree, we see there is a change in the distance of the cow from one position to another position. Okay. Or one location to another location. So when the change happens, it has to happen with respect to one fixed point. Okay. And this fixed point is called the reference point. Okay. So reference point is a fixed point. So in the same example, if the cow is grazing at point A at suppose 10 a.m. and at 10:30 a.m. if you see the cow is at different position B, then we say the motion has happened. So what really happened here? The distance of the first point, or the distance of the cow at 10 o'clock from that tree, is different from the distance of the cow from the tree at 10:30 a.m. And then we can say that motion has happened. And we measure how far or is the cow moved or not, or so for that we have fixed a point, that is the tree, and this tree is behaving like the reference point. And very interestingly, if you attach some scales, okay, with that reference point O, so some scales like, you just attach, we call it axis, so x-axis with scale 1, 2, 3, 4, something like that, and maybe a y-axis also. So if it is a two-dimensional motion, means motion happening on plane, okay, in a plane. So suppose what you can draw on your notebook or what you can see on the screen right now, it is we are using a two-dimensional surface. Okay, it has length, it has breadth, so it is two-dimensional. So that's why we can, to show two dimensions, we can use x-axis and y-axis. So if you attach scales with the reference point, then it becomes a frame. It looks like a frame, and this frame is called a reference frame. So time is also attached to reference frame. Time is also calculated here. Maybe we don't have to give a line always. For suppose we have given x-axis and y-axis. Sometimes we give a time axis also, but even if it is not drawn in particular like this, okay, but still in the mind we have the time we are calculating, then this is the frame of reference or the reference frame. And to study motion, we have to fix our frame or the reference frame. Okay, so we have to fix that. Okay, we are measuring the motion. For that we have fixed one initial point that is called the 0 or the reference point, and from that point, suppose one object is a certain distance away. So suppose this distance is r distance away. Now from here the object moved and reached another point. Okay, so now we have two locations, 2 points. Okay, so let's the first be the r1 and the second one is r2, and we can name the positions as position A and position B. So position is a unique point in the reference frame. It cannot be, the same point cannot have two addresses. So if we say this is point A, it means this is the only point that is called A. Okay, so any other point will have some other name, will have some other address. That's why we call it position. Okay, and position is always fixed. Position is a unique point in the plane or in the space with respect to a reference point. It has directions also. So it is not just the position is a point. It has a particular direction, in which direction that point is situated. So we can always answer these questions very easily if we have fixed the reference point, the reference frame, that what is the position of an object and where is the object situated. So these questions can be answered by the term called position. And then you have heard this word again and again, motion. So what is motion? If there is a change in position of an object. So object moves from position A to position B. So change in position happens. Then we can say the motion has happened during the time or during the given time. And if the position of the object doesn't change, if the object stays in one point forever, or not forever, but for a particular period of time, then we can say the object is at rest. Acceleration is the rate of change of velocity. It means it is actually velocity by time. The way we did average velocity, the same way we can do average acceleration, and that is actually a bar over small letter a, that is equal to change in velocity. So change in velocity is velocity 2 minus velocity 1 divided by the total time consumed. So time 2 minus time 1. And this can further be written as change, that is delta gives the change, so change in velocity divided by the change in time or time elapsed. Acceleration actually shows that the object is speeding up, okay, or it is slowing down. So when the brake is applied in a car, then what happens? The car stops gradually. So there can be a constant rate of velocity on highways, maybe 100 kilometers per hour. But when the brake is applied, the velocity of the car reduces, okay. So let it be in the case of speedometer we see. So let's talk about speed. The speed is from 100, it becomes 80 first, then 70, then 50, 30, 20, and finally it can be stopped, halted to 0. So this is negative acceleration, or we call it deceleration. And again, if we speed up the car, if we press the accelerator, the car picks up the speed. Okay, if it is in a particular direction, then we can say that it picks up the velocity, and the velocity gradually increases. Okay, so this change in velocity with respect to time is acceleration. As we found the instantaneous velocity of an object, we have to find the instantaneous acceleration also. What is the acceleration? What is the rate of change of velocity at a particular time? Okay, at a particular instant. For that, we will do the same thing what we have done with the velocity. So if we have to find A, that is the instantaneous acceleration or simply acceleration, we have to limit the time that delta t, that should be raised to 0, and then the ratio delta v by delta t, and this you can write as dv by dt, and this ratio is called the acceleration. When we do the graph of this velocity and time, and this graph can be known as velocity time graph, so the y-axis shows the velocity and x-axis shows the time. And if you see something like this, it is a curve or a straight line, which is also called a curve. And let's define, there are two instances of time here. This is time 1, okay, and then this is time 2. For these two instances of time, the velocities are different. If you see, for time 1, the velocity is at this point, so we call it v1, first velocity, and for t2, the velocity is somewhere here, and this is our v2. And this change of velocity is actually from v1 to v2, and this distance shows the change in velocity. Okay, on the graph the distance shows the change in velocity, that is v2 minus v1. Okay, if you draw v2 minus v1, this length right here on the right hand side, and the change in time, that is here, then it looks like a triangle with the graph we have shown in the red color looks like a triangle. In this triangle, if we say that we have a theta, then the perpendicular is actually v2 minus v1. Okay, this is the same ratio on your velocity axis or the y-axis, and this is t2 minus t1, your base of this triangle. And from trigonometry, you know, tan theta is equal to perpendicular by base, and perpendicular is v2 minus v1 divided by t2 minus t1. And this is actually, what is v2 minus v1? We have already shown it, it is delta v, and t2 minus t1 is delta t, and this is our acceleration. So acceleration is actually equal to tan theta for a given slope, and we can say that acceleration is actually the slope of the tangent of the curve. Okay, maybe all these terms are new to you and it might be confusing, but for now just try to recall this. Keep in your mind, the more you will be doing all these kind of terms, and you know, you will do problems and questions, then all these terms will become very easy for you. The same way we have known that there is zero velocity, there can be zero acceleration. It means the velocity of the moving object, for example a moving car, is not changing, it is fixed. Suppose it is the car is moving at 50 km per hour in towards north direction, so that is the velocity, and it is not changing. The same amount of pressure is there on the accelerator, so there is no change, it is just constant. It simply means as the time passes, the velocity is not changing, so the velocity is actually just a straight line parallel to the time axis. So the velocity v is fixed, it is not changing with respect to the time, and this is actually zero acceleration. Acceleration is equal to 0. We can do more graphs like this. So if our graph is of the velocity time graph is something like this, then it is positive acceleration. Okay, this is velocity time graph, keep in mind. And if your velocity time graph shows the velocity something like this, it means with the passage of time the velocity is going down, so it is negative acceleration or deceleration. Okay, and as I shown you earlier that if the velocity of the object is fixed, it's not changing with time, then in the velocity time graph it is zero acceleration. So in the first case, acceleration is more than 0, second case acceleration is less than 0, in the third case acceleration is equal to 0. And if this was velocity time graph, and if we replicate the same kind of motion in a position time graph, so this is position time graph, and if there is any acceleration in the motion, Okay, if the velocity is changing positively, it means the velocity is increasing with the passage of time. To show this in position time graph of the object, you will see something like this. The curve is like U-shaped. Okay, and for the negative acceleration in the position time graph, the curve will be inverted U shape, something like this. And for zero acceleration in position time graph, the curve will be a straight line. Okay, straight line, either this or this or this. Any straight line will show that the velocity of the object is constant. It is not changing. Okay, though it is position time graph, but it also talks about the velocity. Okay, so you can analyze these things by yourself also. Okay, you are watching the video here, you are trying to learn the concepts of physics, but you should also go through the NCERT book, so that whatever you learn here, you can reconfirm it, you can have more confidence in what you're doing. So going back to your book is an amazing thing, because you are revising also, you're trying to write your own notes also. Okay, so that's it about the acceleration. We will be doing some of the problems, some of the graphs we have to do, and then we will come to a new concept. It is kinematic equations for uniformly accelerated motion. Let us look at average velocity, average speed, and instantaneous velocity. You have learned from your class 9th science book that average velocity is the total displacement divided by the total time. We write it as a small v and a bar over it, which shows that it is average, and average velocity is equal to total displacement divided by total time consumed or elapsed. Let us learn this through a position time graph. Here, the y-axis tells about the position and the x-axis tells about the time. Okay, now let's attach scale with the frame. So we have, suppose this is 2 seconds, then we have 4 seconds, 8, 10, 12, 14 seconds, something like this. And on the position axis, let it be 10 meters, 20 meters, 30 meters, and 40 meters. And for a given motion, let us draw a graph. So let's draw a curve. Let us analyze the graph. At time t is equal to 0, so t is equal to 0 is this time. At this time, we see the position of the particle or the object is somewhere 8 meters from the origin of the reference frame. And let's say that at time is equal to 10 seconds, the position of the object is 40 meters from the origin or from the reference frame. So for this motion, the change in position is from 8 to 40 meters. And the time elapsed for the change in position is from 0 to 10 seconds. So our average velocity, that is equal to total displacement by time consumed, and total displacement we can show it by delta x, that is the change in position, divided by the time consumed, so that is delta t. Now the value of delta x is from 8 meters to 40 meters, so change in position is 40 meters minus 8 meters, and the time elapsed is 10 seconds minus 0 seconds. So because it started at 0 and it goes till 10 seconds. And we can say it is 32 by 10 meter per second or 3.2 meter per second. And that's our average velocity. Now if we reduce our time elapsed, so earlier it was from 0 second to 10 second, now make it from 2 second to suppose 8 seconds, somewhere here. For this, we see that from 2 seconds to 10 seconds, the change in position is from 10 meters to 25 meters. So our delta x by delta t will become 25 minus 10 meters divided by 8 minus 2 seconds. So that is 15 by 6 meter per second. And if we keep, reducing the time, then what happens? Suppose further we can reduce it from, suppose 3 to 7 seconds, and even reduce it, and then finally we see that we can find the velocity at a particular instant, like reducing the time, making it closer to zero, like exactly at one point. And mathematically we can write it as, if we reduce the time, so we limit the time limit raised to 0. We approach towards 0 for the duration of the time. Then what happens with the ratio delta x by delta t? And this ratio with the limit is called the instantaneous velocity, and mathematically it is written as dx by dt. Because from the period of the time, we have reduced it to an instant of time, at a particular instant of time. Also understand that we can never reach time is equal to 0. If we reach time is equal to 0, then it means the denominator of our ratio is divided by, like it becomes 0. So nothing can be divided by 0, then we will get a weird answer. So that's why we go very close to 0, but we never reach 0. And everything related to this kind of mathematical, science and calculations comes under a branch of mathematics which is called calculus. And calculus is really smart, because to define this instantaneous velocity, if I just want to write the definition, I will be covering half of the screen, okay? But mathematically, it can be shown through the calculus that dx by dt is the instantaneous velocity. So half of the screen writing can be compressed in just a very small formula. So differentiation is that part what we are dealing here in calculus. So this whole ratio is called differentiation of the x with respect to time. That comes from the fact that calculus is divided into two broad parts. The one is called the differential calculus, and the second one is integral calculus. What we are doing here is, we are doing the differential calculus. Wherever you see something like dx by dt, something like, wherever d is there, so there we are doing differentiation. And what exactly is differentiation is, we are breaking it into very, very small part, okay, to find the most exact ratio when the denominator approaches close to 0. Let us see one other scenario in your position time graph. Suppose this is time, this is your position, and there is 0. Suppose the motion is depicted here as a straight line parallel to the time axis. It simply means that time is changing, but position of the object is fixed. It is not changing. It is not going up or down. Okay, so it is fixed at a point. It means here the average velocity is actually 0 throughout this motion. Why? Because there is no change in position or no displacement. Also, suppose we have, let's mark 2 points on the time frame. So suppose this is one mark and then other mark is there. And now from here on if we see a graph something like this, what happens? There is a change in position, but at the time instances, suppose time 1 and time 2 is our two time instances. At these two time instances, the position of the object hasn't changed. It is still again fixed at a particular point on the displacement axis or the position axis. In this scenario also, we can say that for the motion from time t1 to t2, the average velocity is 0 because the position remains the same. It is something like, suppose an object started moving and it moved, but it came back to the same position again. Okay, so position remained the same for two given times, t1 and at t2, because after a certain period of time, again the object reached the same point, means that there is no change in position. Okay, so in that case also your average velocity is 0. But the average speed is a totally different thing. It is the definition of average speed is average speed is total distance covered by total time consumed. So in the scenario where we got this average velocity is equal to 0, for the same scenario the average speed will be different, because here we have to measure the length of the path the object traveled. That is the total distance. Total distance is different from total displacement. So that has to be divided by the time consumed. In the case of circular motion, when an object moves on a circular path, what happens here? There is a circle, and what happens? Suppose the object started from one point, okay, and after a certain duration of time it reaches the same point. So here what happens? The displacement is not changing because the initial position and the final position of the object is the same, but the distance is different thing. For a circular path, if the radius of the circle is r, then the distance covered is 2 pi r, the length of the circumference. Okay, so and that is divided by t2 minus t1. This is your average speed. But for the same motion, the average velocity is 0, because the object came back to the same position. So change in position is initial minus final is actually 0. It is the same position. And that is all about average velocity, average speed, and instantaneous velocity. Now we are ready to come back to motion in a straight line. Motion can happen in a straight line, just like suppose there are two stations and there is a straight railway track. So this kind of motion is a straight line motion, and we name it the rectilinear motion. Rectilinear motion. Object in rectilinear motion can go only in two directions, either the right side or the left side if you are watching it on the screen, or to say that either in the positive direction or in the negative direction. It is not a requirement that the motion has to happen only in the horizontal direction or the vertical direction. Okay, motion can happen in any direction, but if the motion is in straight line, then it is rectilinear motion. So the vertical motion up to down or down to up is also rectilinear. The horizontal, already I mentioned, that is rectilinear motion. And even the slant lines, if the line is straight and if the object moves from one position to another, okay, on this straight line, then it is example of rectilinear motion. And chapter 2 is all about this kind of motion. Rectilinear motion is also called one-dimensional motion. Why? Because the motion happens only in one dimension. That is, only in one axis, maybe x-axis or y-axis, but it happens only in one dimension and it has a straight line motion. Now think about a scenario in which the object is on this screen, what you are watching. So object is right here. Suppose this is your point A, and we have one initial point or the reference point O. Now if from point A to point, suppose point B is there somewhere, and if an object moves from point A to point B, either in a straight line or maybe going somewhere in some direction and coming back to point B, these both kind of paths suggest that the object is in a two-dimensional motion. Why? Because we can measure these kind of motions in two different directions. Example can be if the car is moving on a road, and if the surface is a plane surface, then it is an example of two-dimensional motion. So in that, we have to ignore the flyovers, because if we include flyovers, it means the motion is not just in two dimensions, but sometimes the motion also happens in third dimension. That is, the object has gained some height. Along with the length and breadth, the object also gains some height if it goes on the flyovers. So if we have taken the example of car, so if car moves within the city, inside the city, and if the city has no flyover, then that kind of motion is a two-dimensional motion. If the city has flyovers, and if car goes on that flyover, comes back to the ground, so in that case, the motion happens in three different dimensions: length, breadth, and also height, and that is called three-dimensional motion. Now we are ready to understand what is the difference between distance and displacement. In chapter 2, we have to stick with one-dimensional motion, but just to understand the concept of distance and displacement, I'm using a two-dimensional frame. In a two-dimensional frame, suppose there is a 0, the point of origin, and then there are 2 points on this plane. Let the points be A and B. If our object is at a point A, then we call it the position of that object. So A is the position of the object with respect to the origin O. And if it moves on point B, then now the position of the object is B with respect to the origin O. And there are two possibilities of this kind of motion. Either the motion can happen in just straight line from point A to point B, or the motion can happen in some other directions, not in a straight line. From this picture, we can say that the length of the path traveled, this length, is called the distance. Okay, this path can be different. So another example is the path taken by the object is different. So it is different path, but if we calculate the length of this path, this length is called the distance traveled. So from point A to point B, there can be many different distances. Okay, so there can be a short route, there can be a long route, okay, there can be a busy route, there can be a very relaxed open route. And if we measure the length of these routes, that length is called the distance. When we talk about distance, we don't talk about directions. We only talk about the magnitude, the quantity. And that is, 20 meters, 5 kilometer or 500 kilometers, something like that. But the shortest distance in a particular direction is called displacement. So if we talk about 2 points, point A and B, so the displacement of point A and B is the shortest distance. That is always a straight line, is the shortest distance. And if we define also the direction, in which direction, then we can say that quantity is displacement. And displacement has direction attached to it. Let's look at the same scenario in one-dimensional motion, that is in one direction. So what is the distance in one direction? So if our purpose is to find the distance from point A to point B on a straight line, so this is the distance, okay, the length between these 2 points is the distance. But when the motion happens, it is not fixed that the motion will only happen just like this. The motion can also happen, the object first goes to point C and then comes back to point B. In that scenario, we have to calculate the distance the object travels. So from 1 to C, that distance, plus from C to A, and then from A to B. So we have to add all the distances if the path taken by the object is first it goes to C and then it comes back to A, then it goes to B. So in the case of distance, we have to add all the paths taken. But if we talk about the displacement, so displacement is again the shortest distance. Okay, The shortest distance from A to B is this straight line from A to B. Though the body or the object travels from A to C and then it goes back to B, in that case also the displacement is only the shortest distance in a particular direction. So if it is from A to B, then we will say that the distance of the path from A to B towards B. So we have given a direction towards B. So in that case we can say this is a displacement. Here also we have to understand this in a way that there is one reference point, that is our point O, and with respect to this point, the point of origin, A is the position of the object when the object is at A. So when the object is at A, then the position of this object is A with respect to origin O. Okay, and then when it is at B, then the position of the object now becomes B with respect to the origin O. Okay, now what we are doing is actually in displacement we are just calculating the distance between two positions. Okay, so we try to learn the change in position, but in distance we just try to calculate the length of the path. So let me write the definition. Length of the path is distance and change in position is displacement. Let us take a few more examples of the motion. So suppose the motion is depicted by a curve in the graph, okay, and what we have taken right now is our xt graph. Xt graph means position time graph. So where there is position and time axis, and suppose there is a curve something like this. Now the question is raised that, do you think this is a valid motion? Is this kind of motion possible, what we can see in the position time graph? The answer is no. Let me tell you why. Let's analyze the graph. Here, for a particular time, for a particular instant of time, let's say our time is t1. For this time, we can see that there are two given positions. Okay, so on the x-axis, on the position axis, there are two values. For the same time, for the same instant of time, there are two positions. Okay, is this possible? At the same time, can an object be at two different positions? No, it is not possible. So this is not a valid graph. Or let's take another example. Let's take in the position time graph, there is a curve something like this. Now here, if we analyze the graph, we see that for a particular instant of time, let's again take one instant of time, that is t is equal to t1. For this instant of time, there are one position here and another position here. Position is depicted by the position axis, so there is some value. Let's say this is x1 value and this is x2 value. Okay, so x1 value and x2 value are the positions of the object for the same point of time. At one time there are two positions given, which is again not possible. So this kind of motion is not possible, or this graph or curve shows incorrect motion, okay, on the position time graph. We can take another instant of time, let's say another instant of time, this, and if we what are we doing? If we draw the parallel line to the position axis, so you know the position axis is there, and if we draw any parallel line to that, that is any vertical line, and if the vertical line cuts the curve more than once, here we see it cuts here and the same line cuts the curve somewhere else. So if the vertical line parallel to the position axis cuts the curve more than once, then that motion is not valid, and that's the trick. So whenever you are given with any graph, position time graph, and any curve is given to represent a motion, the first thing to check is that, is this motion valid? How can we check that? Simply, we can draw the parallels to the position axis, and if it cuts the curve more than once, then the motion is not valid. But here in our third example, we see that the vertical lines parallel to the position axis cuts the curve only once everywhere. So in this way we can say this motion is valid. Another important thing is that in the position time graph, so suppose we have a position time graph, let's draw it. Okay, in this graph a curve is shown, maybe something like this. Is this curve possible? So this curve is not possible. Do you know why? It seems like, it looks like very cool. I mean, if we use the vertical line parallel to the position axis and if we cut the curve, we see that it cuts only one time. So it means the graph should be valid, but there is one problem with this graph. What is the problem? That the time axis can have only positive values, because time cannot be negative. Time starts from 0 and it goes in the right hand direction. Okay, so time cannot be negative, but we see here that the curve is extended on the left hand side of the position axis. Okay, so that is it is left of the this position axis, giving negative values of time. Okay, this is the 0 of the time, and all the values on the left of this 0 is negative value of time, which is not possible. Time cannot be negative. So again, this graph is not possible. Now let's take the example of velocity time graph. Okay, in the velocity time graph, again a curve something like this is not possible. Why? Because for the same instant of time there cannot be two values of the velocity. Okay, these are the velocities, so this is v1 and v2, so there cannot be v1 and v2, two different values at the same time. Okay, all right, let us now start with kinematic equations for uniformly accelerated motion. We know these three equations, very popular ones. V is equal to u plus at, the first one, and then x is equal to ut plus half at square, and sometimes this s is written as this x is written as s. Okay, it is the same thing. We are talking about the distance. And the third one is v square minus u square is equal to 2ax or 2as. Now you must have seen these three equations in your class 9th science book. Here we will try to derive these three equations using calculus, using actually integration. So it's quite interesting. You just have to focus. You have to put your focus here, like what all the steps we are taking, and that is it. You don't have to master integration before you solve these equations, but you just have to focus for this purpose. For deriving these equations, we are going to use integration in a very simple and easy way. All right, so let us start. For a given motion, when we said that this is uniformly accelerated motion, that simply means that a is fixed. Okay, a is a constant. It is not changing. The acceleration is not changing. Okay, in this kind of motion, by definition we know acceleration is equal to dv by dt. That is derivative of velocity with respect to time, or simply velocity upon time. Okay, now if we do the cross multiplication, then what do we get? It is a multiplied by dt is equal to dv. So it is simple cross multiplication, just like this. So we multiply a and dt, and then we multiply dv by a, 1 in the denominator on the left hand side. Okay, so finally we reach at this equality. Now from this equality we actually have given velocity dv. Okay, now if we it is actually the change in velocity. Okay, if we really have to find the velocity, for that we use a sign which is called integration. So it is something like this sign, and then we can integrate our dv, that is the change in velocity. And if we integrate on the left hand side, then we have to integrate it on the right hand side as well. Now what is integration? Integration is actually summing it up, add everything, Actually, dv by dt is a different kind of quantity. It says that for a very small, elapsed time, for a very small quantity of time, what is the change in velocity. But if we have to find the real velocity, what is the velocity of the motion, for that we have to integrate, we have to add all the, not that small fraction of time, but if we increase the time, take the totality of the time, total time, okay. So what happens? Our time is actually from 0 to t, total time is to t. So from 0 to total time t, we have to calculate the whole amount of time and apply this in the formula so that we get the real change in velocity, the big change in velocity. And this velocity has range from initial to the final. V is called the final velocity, U is called the initial, that you have learned in class 9th, okay. And this is the integration. Now what happens? Integration simply means sum it up. So where are we going? From U to V. So actually what is our change in velocity? It is from V minus U on the left hand side. And on the right hand side, if we get any constant, when we do integration, we don't do integration of constant. Always we bring the constant out of the integration. So we will write a, and then we will use the integration sign, and only what is already differentiated, that can be integrated. So dt can be integrated, and dt can be integrated from 0 to t. So on the right hand side, what do we see? It is actually a, and time is, what is the time here? Time is from 0 to t, it means t minus 0. And then we have v minus u on the left hand side, that is equal to a multiplied by t, 80, and then minus a multiplied by 0 is 0. So we'll ignore that, and the equation what we get is v minus u is equal to 80, and this is our first equation. Just write it as our first equation. Now further, if we try to get the second equation, that is all about the displacement or the distance, and for that we have to go by the definition that velocity is actually equal to dx by dt. This we have already done, and if we do the cross multiplication, we see that our dx is equal to v dt. And now again integrating it, we can integrate dx on the left hand side, and we have to integrate the right hand side as well, that is v dt. Now we can fix the limit of this integration, that the quantity dx is actually, let's take it from 0 to a position x, that is the limit. It can go up to x position, okay. And for on the right hand side, the time again dt is there, so it can go from 0 to t. Now the value of v, we can see that value of v is required here. So value of v is already, we found it from the first equation, that is v minus u is equal to 80, or v is equal to u plus 80. So just replace the value in our integral equation. So let's write, it is from 0 to x, dx is equal to, integrating it 0 to t, and then v can be written as u plus 80, and then it is multiplied by dt. And simply what do we see? On the left hand side, it is 0 to x is actually x minus 0, and on the right hand side we see it is actually 0 to t, and then u dt plus 80 dt. Or the right hand side can be modified, it is from 0 to t, and then we can write u dt plus again the integral sign, and then a t dt. Further, what we can write here is x minus 0 is actually x, and that is equal to, let's focus the first one, integral, that is from 0 to t, and integration of u dt. So u is fixed and dt is from 0 to t, that is t minus 0. And then here a is in the second integral, a is again constant, a will come out, and then we will have t inside and dt, and it goes from 0 to t. And we can write x is equal to u multiplied by t will be ut, and u multiplied by 0 is 0, so we ignore that. And then we come to the second one. Here you see it is a and the integral sign from 0 to t and t dt. Now integrating any variable, anything like this t, okay, and if the limit is given, it is beautiful, it is easy to solve. Or maybe x, if we have to integrate it and it is from 0 to t or 0 to x, then in this case the integration is actually simply, and dt is also attached, dx is also attached to it, the integration is simply we square the quantity and divide it by 2. Okay, that is the simple rule for integration here. So for now there is a formula behind it, but for now just understand it. If any variable has to be integrated like t dt, we have to integrate t and dt is attached to it. In this case we simply square the quantity, so we will square t, so it will become t square, and then we'll divide it by 2. Okay, now let's erase this part and let's focus on our equation. So this equation will become a, and this quantity is now t square upon 2. And further we can write x is equal to ut plus, here it is half a t square, and this is our second equation. All right. Now let us come to the third one. The third equation is v square minus u square is equal to 2ax. For that we start with a, that is our dv by dt. Okay, and we can write this ratio as dv by dx, and that is multiplied by dx by dt. In this way we are not changing anything, you know, this dx can be cancelled, and actually it is dv by dt only. Okay, so we can do this and it becomes equal to, now here this dx by dt is actually v, so dx by dt, we know that it is equal to v. So we can write this equation as a is equal to dv by dt, and that is equal to v, that comes from dx by dt, and then it is multiplied by dv by dx. The equation that we finally get here is actually a is equal to v dv by dx. Again we can do the cross multiplication. Okay, so for the cross multiplication we multiply a and dx, and finally we get v dv is equal to a dx. And finally we are ready for the integration part. So we will integrate this equation. Now on the left hand side we can see it is all about dv, so it is the velocity is, and the range of the velocity is from initial velocity to final, that is u to v. And on the right hand side a differentiable amount is x, so it will go from 0 to x. In your book or in some books you can see the values are given x1 to x2 or x0 to x. You can take those values also, it doesn't matter much. This the idea is you should understand how to use integration to derive the equations of motion. Okay, now let us go further. Now we know that if any quantity is something like v dv and we have to integrate it, what happens? If we integrate v dv, actually we have to simply square the quantity and divide it by 2. Okay, so this is what we have to do. But here the limit is from u to v, so we will integrate it by squaring it and dividing it by 2. But that is for the v, but we have u as well, so for u also we'll do the same thing, and we'll square u and divide it by 2. And on the right hand side, a is a fixed quantity, it's a constant, and x dx can be integrated from 0 to x, that is x minus 0. And on the left hand side, what do we see? V square minus u square divided by 2 is equal to ax, or we can say v square minus u square is equal to 2ax. This 2 will go on the right hand side, will be multiplied to ax, and this is our third equation, and this is how we derive it using the integration. Alright, so that is it for the equation of motion. The more problems we do, the questions, it will become very easy for us to understand it, and we will feel more confident again. Now let us do the last topic, and that is free fall. Free fall is a case when under the gravity an object is dropped, okay, and it falls freely. It simply means it falls under a fixed acceleration, that is called acceleration due to gravity. We denote it by g, okay. So g is actually the acceleration by which anything falls towards the center of the earth, okay. So the direction of this g is always downward, okay. But if we measure any distance, vertical distance, that is always upward. So that's why always we consider g as negative, and the value for g on earth is actually minus 9.8 meter per second square. It is the acceleration due to gravity, and the value of g, or g, only works on the vertical component of the motion, okay. That means something going up or coming down, okay. It doesn't affect if the body is going this way, the horizontal component, the x-axis, okay, it doesn't affect on that, okay. You will see what happens when we throw anything, gradually it comes down. When we'll start our third chapter, you will come to know that even in this case, the acceleration due to gravity doesn't work on the horizontal component or the x-axis. It only works on the vertical component of the motion. So if anything is thrown up, or it is suppose velocity is given and then acceleration is given, then you can be asked find out the time. So you can find out the time, and to master it again, I will request, do questions, go through your NCERT book, do the examples there, and also touch upon some questions at the end of your chapter 2. And here we conclude our chapter 2, the theoretical part, okay. If you have any problem, write back in the comments. We can do more lessons on some problems. If it is intriguing problem for you, I will definitely help you out in that. Thank you.